Hey guys, welcome back, and today we will be discussing a problem based on linked list. So I'll show you the problem statement. Since we were solving problems from your SDE sheet, this was the problem that we have to discuss today. Add two numbers represented by linked list. Before that, I'll just quickly check if you guys are able to see me. Yeah, I think we are live. Okay, so fine. The problem is this. So you are given two decimal numbers represented by two linked lists. Okay, they are of sizes n and m respectively. Your task is to return a linked list that represents the sum of these two numbers. So I'll explain you what this question is. I'll take the test case. 4, 5, 3, 4 and 5. So first let's understand the problem statement. So you are given two linked lists here, and you can take this linked list, that this list represents the decimal numbers, correct? So this is, for example, assume it to be a number 45 and assume this to be a number 345. Now tell me what is the sum of these two decimal numbers. You will do simply like this. This will be right, correct? This is how you're going to do. So sum of these two numbers, if I just have to add two numbers, the resultant would be what? You will return what? Let's say this is number n, this is number m, or maybe this is a, this is b. For example, these are two numbers and you have to just return a plus b. That will return you the sum of these two numbers. But the problem here is that these two numbers are actually represented as a linked list, not just as two integers but as linked list. So each digit is actually the node of a linked list, right? So what we have to do now, we know in the linked list, the challenge in this question is that, and also this question has been asked in a lot of interviews, okay? So this is the H1 for this linked list. This is the H2 of linked list. The problem here is that whenever we had two numbers, for example, let's say if this was an array, even if it was an array, we want to actually add the numbers starting from the end position, right? So we might get to the last index of your array, pick the numbers one by one and manipulate our answers like this, right? But here we cannot move in a linked list from the end, that is from tail to head, because our pointers are in this direction. You getting my point? Is it possible for you to be at fifth, this node which is represented by 5, and get the address of this node? No, because in a linked list, if I am at this node, I can only get the address of its next node. This is how a single linked list is designed. So to overcome this challenge, what do you think can we do here? If I simply see, I know that I want to add the last number of this linked list and the last number of this linked list. What is the sum? It is 10, right? The sum will be 10. But if I see, when we add two numbers here in programming, now if the sum is 10, I want to fetch the last of it, right? So 10 divided by 10. Remainder, what is that remainder of this number with 10? The remainder is 0. I want to extract the remainder here, and my carry will be what? My carry will be this sum. Basically carry will be whatever is the sum divided by 10, right? So the carry is 1, and that 1 should go to the previous node of this. But the problem is I do not know what is the previous node, because I do not have its address if I am standing at the tail node, right? So to overcome this challenge, what can we do? Now ideally my sum should be 4 plus 4 8 plus 1 9. So when I see 9 remainder, the sum remainder with 10, which is 9 here, is what? It's obviously 9, right? So this will come here, and carry is what? 0, right? So carry is 0, which will go. Now tell me, 0 will go. Okay, I'll add 0 with 3, but do I have any node to add? So basically this is baseless. I'm just telling you that what is the challenge. Okay, now to overcome this challenge, what can we possibly do? So understand this thing. Anyway, I want to traverse from the end of my linked list in both the lists, right? This is your list 1, this is your list 2. In both the lists, I want to traverse from the tail node, correct? If I want to do, why not go ahead with reversing the linked list? This is your linked list. If I reverse my first linked list, it will look something like this. 5 is pointing to 4. We will write a reverse function which will reverse the linked list, which we have already done in our previous question. You know how to reverse a linked list. So we'll write a function of reverse. Now my new head h1 will be pointing to 5, right? Just a second, I'll just quickly check if I am absolutely visible to you. Yes, we are. Fine, right? So apply the same function on the next linked list. So when I do reversal of second linked list, my new head will be 5. 5's next will be 4. And 4's next will be 3. This is how my two lists are going to look like now. Now h1 is pointing to 5 and h2 is pointing to 5. Fine. I will now traverse in the same direction what I have as of now after the reversal. Now what is your target? Your target is that you calculate the sum. Fine, I calculate the sum. 5 plus 5 is 10, but we have to calculate in the similar way as we are adding any two integers, right? In which we will extract the sum divided, the carry will go as sum divided by 10 and sum remainder 10 will come here as a new node. Now this will be your new list for which I will take a dummy node, right? This is going to be your new list in which you will have a dummy node whose next will be pointing to this node which I will be adding here. So let's say this is your dummy node, dummy, whose data you can take anything, -1, 0, whatsoever you want. This is your dummy node. Dummy nodes next should be pointing to what you are going to write here. 5 plus 5 is 10. So sum remainder 10 should go here at the next of dummy. The value should be sum remainder 10. So 10 remainder 10 is what? 0. So carry will go as sum divided by 10, which is 1. So 1 goes here, right, as your carry. Now 4 plus 4 is 8. Now basically I am traversing through linked list 1 and linked list 2 simultaneously. Currently, let's say this is my cur 1. Cur 1 was here. This is my cur 2. Cur 2 was here, right? So let me write it properly so that you guys can have a clear understanding. I want you to understand within one iteration as I am trying to do. This is your node having data of 5, right? This is your node with data 5, whose next is pointing to 4, right? Whose next is pointing to 4 and whose next is null. So this is after reversal. After reversal of both lists. Fine. Right? Whose next is pointing to null. Correct? Cool. Now, while I'm writing a simultaneous pseudocode here, while what? While h1 is not equal to null, or h2 is also not equal to null. If one of them is also null, then also I'll go within the loop. Okay, I'll only stop when both of them are null. Okay, so what I'm trying to do, I am taking a pointer, I'm taking a cur 1 which is pointing to head 1, this is h1, and cur 2 which is pointing to head 2, right? This is head 2. So right now cur 1 is here. I am going to do the sum and take a new list whose dummy node, I'll take dummy, this is your dummy node, whose data is actually 0 and whose next will be pointing to the new head of this. So new head will be the sum and I'll take 0 here, whose data is 0, right? And 1 is carried over, this is your carry. 4 plus 4, 8 plus 1, 9. So new node, its next will be pointing to this sum which is 9, right? Carry is going to be 0. Now see, h1 is null, but I will still remain in the loop. Whenever your one node is null, just treat it as 0. The data of that we will put a check where if I find a node to be null, I'll take data as 0, right? Add it with the non-null value. So this is 3 plus 0 is going to be 3. So the new node will be of value 3 and its next. Now see, this is already null and this has become null. This is when I'll come out of the loop. Now you see that I have a list 093. What I actually wanted to return in the original list, this is 390, right? The sum of two numbers treated as they are given. I should be returning a list whose head is actually pointing to 3. Don't you see that this is complete reverse of what we want, right? So we have already returned the reverse function. We just have to do one thing. Just pass dummy dot next to your reverse function. In your reverse function, just pass your dummy dot next as your node from which you want to reverse. So on reversal, you are going to get a result which will be, whose head will be pointing to 3, 3's next will be pointing to 9, and 9's next will be pointing to 0. That's how your linked list is going to get reversed, and you will get exactly the list of as a sum of two numbers given as linked list. Got it? So this will be returned. This is the head which is going to be returned. I hope you understood. Is there any doubt in the explanation part? You guys can write it in the chat. If you have any doubts, I'll show you in the code how we are going to handle these things. But if you have any doubts, let me know, guys. I think there are no doubts as of now. Now I'll just show you how we have written the code here. So see, this was the function that was given to you, right? What I'm doing here, I've already written a reverse function, which I'm not going to get into details because we have done the question itself on reverse. We do nothing. I'll take it again because it feels like, for those who have not watched the video, maybe you have, if you have some doubts. How do you reverse a node? I take a current node here. Okay, let's say this is your current node. Then I take a pointer to the next node of it. So maybe temp is pointing to cur.next. Now you just remove the, now what you do, this is actually your, maybe you can take, for example, current is here. Now what you do, temp.next. Okay, you have to do just simply like this, that temp, this is your previous node, okay, and this is your current node, and then you have a temp.next. So current.next is pointing to previous. I'm not telling everything, just for you to recap it. Current.next is pointing to previous, so this points here, right? You already have the address of this node, which is this. So next, what you repeat the same thing until your temp becomes equal to null, current becomes equal to null. That's what you do here. Okay, that's exactly what we have written here. While your current is not equal to null, your temp, you are taken the address of the current's next, so that now you can form a link to the previous node. Current.next is previous. This is what we are doing when we are making a link this way. This is current.next is pointing to previous, right? Then previous, then we are going to do the same thing. So previous comes here. This is where your previous points, and current points to temp, and then repeat the same process. Fine. And finally, you return the previous, which is the head of the reversed linked list. So first step, as I told you, we are going to reverse both the linked list. 45, 345, they will become 54 and 543. Why? Because in addition, we start from right to left. So to make that possible in a linked list, we have reversed them. Now carry is the variable you have taken. Dummy node, as I told you, we have taken a new dummy node so that we can access the actual head of the reversed linked list on doing the sum, right? So node current is pointing to dummy. This is for the traversal through the linked list of what we are going to create after doing the sum. Now this is where we are doing this thing. Over 45 and 345, when they are reversed, it becomes 54 and 543. So h1 is pointing to 5, h2 is also pointing to 5, as I've already shown it to you. I'll just take this part and show you in the code, in the dry run that I have already done for you guys. And then if you still have any doubts, you can ask me. See, you all can see here, what have I done here? Well, while h1 is not equal to null, so this is actually this h1, right, which is actually pointing to the reversed linked list head node 5, right? Int y, let me take this one. closer. Okay, fine. Now what? Okay, so this is your h1, right? This is your h2, fine. X, what I have done here, if h1 is not null, which is true, we are taking simple h1 dot data, but when h1 points to null, in that case, what is the value of null node? We do not have a value for a null node, so that is why I have put a check here, so that whenever you find a null node, take it to be 0, because I have to add a carry to this node, right? A non-null node. So in order to have a value, we will take 0 if the node is null. Same goes for y. This is int x, this is int y, which is the value for this node, right? If it is null, then take it 0. Now you have to take the sum, which will be added here. This is the actually sum, right? This is what? This is equal to x plus y. Initially your carry is 0. Just give me a second. Initially your carry is going to be 0, correct? Now what? Your cur dot next. Current is, you remember, current is right now pointing to dummy node, right? So current will be actually iterating through these nodes, which is the final what you have to return. So current is here. What I'm doing, current dot next, you are forming a new node, which is actually x plus y plus carry, which is this actually. Where is it? Which is sum. So cur dot next is new node, sum remainder 10. I told you why remainder, because if in case we have a carry, that will be assessed like that. Now current dot next is pointing to cur dot next. Now my cur is pointing to 0, right? Now it is saying if h1 is not null, if still h1 is not null, then you move h1 to the next pointer. We are putting an extra check here. Same goes for h2. If it is not null, now your h2 is pointing to this node. Do the same thing. What is your x? Again, if it is not null, take the value. Y, if it is not null, take the value. So your sum will be 4 plus carry was 1. So 9. Now this will be added as a new node, which you see here. Cur dot next. Now this was my current dot next is pointing to new node with a value of 9, right? And which is actually sum remainder 10, which will be 9 only, and your carry in case this will be 0. Now current will be pointing to this node. Cur is equal to cur dot next via this. Again, h1 is null, so h1 is not null, which is not true here. Come to the next condition. If it is not null, so h1 actually stays here. h1 is not equal to null. h1 is equal to h1. h1 is not null, so h1 still goes here. h2 still goes here. Now you see, if carry is greater than 0, then current dot next is point. This is we are doing this after we have come out of the while loop. Okay, now come back to your while loop, first line. So h1 now is null, so your h1's data will be 0. Okay, so that you get a proper sum will be 0 plus 3 plus carry was also 0. So now this will be your new node, will be actually sum divided by sum remainder 10, right? And current next is pointing to this new node, which is sum remainder 10. Now current is pointing to this node. Fine. Okay. Now what? If h1 is not equal to null, which is not true. If h2 is not equal to null, which is true, so h2 goes here. Now you come again, check the condition. Now h1 is also null and h2 is also null. That is when you come out of the loop. So there could be a case where, for example, you have some carry value, right? For example, if this was 9 plus 3, what? 12. So 2 and 1 still is in carry, so you would add 1 here, right? That for that case we have put this condition. If carry is still greater than 0, so cur's next should be pointing to new node with a value of carry, and then you actually reverse these entire nodes. Again, make a call to reverse function, so that you get a final node like this 390, and you return the new head. That's all. Fine. So that is all about this question. Okay guys, so what have we done in this? We have mainly made use of reverse function for all the 3 linked lists. We have made use of reverse thrice, then we are also iterating over it, so it revolves all along om plus n. Although we are doing it more than m plus, means more than one time that we are going through in the entire linked list, but dominating factor would be big O of m plus n. Got it? So have we taken any extra space? Obviously we are creating a new linked list, so nodes space is what we are taking extra. So see, max of n plus m, that's the auxiliary space we are taking, as we are returning a we are creating a new list for the sum, that is why. So that is all about this problem. I hope you all understood this. So if you guys have no doubts, I'll just wrap it up. Okay. I already iterated through the entire test cases, and also if you still have any doubt, I'm sure that this must be clear by now. If you still have any doubts, you can try to go through the video again. But I think that's all for today then, everyone. See you all in the next lecture tomorrow. Till then, bye bye and take care. Fine. Thank you.